Hey friends, welcome to another session where we share with you the solutions to tackle some common questions you might face in the end of your examination. So we will move forward with the second question of the direct inverse proportion today. So earlier we have shared the inspection method for the other one question. If you miss it, you could check it out in another one of our videos. So for today, for question 2, we are going to cover very common questions that students will tend to ask me. And these kind of questions typically are pretty short because they don't give much things. And because of the fact that there's quite a lot of unknowns, they actually cause students to be pretty confused about it. Okay. So we are going to first generally cover the idea that whenever they give you such a phrase, right, like they say y is directly proportional to X, or Z is inversely proportional to W. Whenever they give you any of these phrases, immediately you got to translate this English sentence into a mathematics equation. Okay, and what I mean by that is whenever they say inverse proportion, we will always change it to based on the first quantity mentioned equals to K divided by the second quantity. This is for inverse proportion. All right, likewise for direct proportion, you're going to select the first quantity equals to K times of the second quantity. All right, so the difference is for inverse, you put it as K divide. For direct, you put it as K times. Now, of course, when it comes to method-wise, there's different teachers, different schools of thoughts. You might feel that the formula here seems to be a little bit different from what a school teacher might tell you, especially because of inverse proportion. Because one of the other formulas that your school might teach you is they will put it as K is equals to the first quantity multiplied by the second quantity. Now, in fact, if you see if you understand the manipulation of algebra, if you move the denominator element here, the quantity, into the left-hand side, it will become some multiplication just like that. So it's just the idea of manipulation. But personally, I feel that the first formula that I put at the top, when you just think about inverse proportion as K divide, it seems to be quite smooth with regards to memorizing it. Yeah, so get this into your head. Direct proportion is K times, while inverse proportion is K divide. Yeah. All right. So there will be variations of such questions, of course. And some of the questions that you might face might be, they tell you like, let's say y is another sentence that says y is equals to 2, and then z is equals to 16 or something like that. Okay. So if that's the case, then you would want to substitute the numbers in for you to find the unknown k. This is example. Okay, anyway, I'm going to go back to the question first. So when they say y varies inversely proportional to square root of z, so you will put y first. The first thing you mentioned is usually the first that you write on the left. And you know that it's inversely proportional. So it's k divided by the square root of z. Now, sometimes the question could be a little bit hard to spot if they never put a symbol of square root. Instead, maybe they will put it in words. Like sometimes they will say, oh, square of z, square root of z, the cube of z, etc. So somehow when students see them in words like that, they tend to miss it for some reason. Okay, they will just put it as z, but without putting all this extra powers and roots that is related to z. So take note of that. Okay, so must take into account the words they mention regards to z. Okay, sometimes it's not just a simple z. Yeah. So with this formula here in the example, if they, let's say they give you the value of both y and z, you can then sub that in. That means you substitute the y as 2 and change the z inside the square root to 16. Okay, you're only changing z to 16, not the whole thing to 16, because you're only changing z, right? And then you will basically be able to solve for k for this type of questions, right, by multiplying by 4. And then in this type of question also, the question will ask you to basically connect an equation connecting y to square root z. So then after you obtain k, your final answer will just be changing k to the number that you found out. And the other two, of course, will still stay as variables. Okay. All right, so back to this question. This question, however, doesn't have the any way to find k because they didn't give us any value of y or z, right? So the only thing we could do is just to write the general formula connecting y to square root z without being able to find k. And because there's nothing else we could do to find out k, we will jump into the question, and the question says that z increases by 44%. All right, so if it increases by, it means you have to add 44% to the original, right? And original for anything should always be represented by 100%. So you want to connect 100% to z, and most of the time we will put equal sign, but there are some schools that don't accept this way of writing because they say, why do you say that 100% is equals to z, but z is supposed to be a number, right? It's just that the number of z, the original z, is represented by 100%. So if they don't accept you to put an equal sign, you can actually put it as REP, the short form for represents, okay? And of course, we will find the 1% next, just like how we normally do a units method. We will use z to divide by 100 first. Before we find the new z, which is going to be 44% plus 100, which becomes 144. And we use that to multiply by z over 100, okay? It's up to you whether you want to leave it in fraction or decimal. Decimal as a coefficient of z. So we want to basically continue to say that now our z has become 1.44z. All right, and since it's a new number now, the next thing we're going to do is to substitute the new z into the original equation here. All right, and the next thing we want to do is to try and separate the number away from the algebra portion, which means that we will pull out the number square root of 1.44, square root of the whole thing, right? Which means that it will be square root of both number as well as square root z. So I want to try and remove this number from the algebra portion, okay, so that we can create like a coefficient. Like if example, if we're able to get something like 4 times of k square root z, like a coefficient here, then we will be able to compare the original y with this, right? That's the idea of the question here. So square root of 1.44, square root of that is going to give you 1.2. And then you will pull that out from the algebra portion to become the coefficient. All right, and personally, I don't like to see the denominator having a number there because a lot of students might not feel that it's easy to understand, especially now it's a decimal, right? Just remember that if a number there's only a number in the denominator, the numerator will just be 1, right? Because k is just equals to 1 times k. So in fact, if you want to separate the number from the rest, the coefficient is actually 1 over 1.2. So we want to simplify that just by pressing it in the calculator, which will give us 5 over 6. So if we create a coefficient of the number of times of the algebra portion here, then we will know that the new y that we just found out here, based on the new z value, is equals to 5 over 6 of the original. Can you see that the original portion algebra expression is exactly the same, right? The only difference is that it has a number now. Before that, if there's no number, it just means there is 1 unit, right? Just one such unit of this algebra expression. And now it becomes 5 over 6 of that. So does that mean we have solved the answer? Have we solved the question? No, we still are lacking something, right? The question is not asking us for this new y. They're asking for the percentage increase, percentage decrease in y. And for this to work, I always tell my students to change them to express what they want as a fraction first. Since the subject they want is the decrease, Decrease should be the numerator divided by the original. All right, whenever you deal with percentage change, the fraction denominator will always be the original value. And then you convert this to percentage by multiplying by 100. Okay, and of course, in the calculator, you will just press times 100 literally. But then because in Singapore, the examiner will always want you to put down the percent symbol whenever you're converting to percent. All right. So take note, you do not press the percentage sign in the calculator, otherwise the answer is affected, right? I think by now you should be expert in this, right? So let's get into the numbers wise. I want to have the decrease. So I'm not going to write down the algebra portion because it will make things very complicated. We just know that this is like equivalent to 1 unit, right? It's the same as a 1 unit of this thing. And then now this thing becomes 5/6 such units. We're just comparing the coefficient, right? So the decrease will be from 1 becoming 5/6. We minus that to find the difference. That will be the decrease. And the original, what number do we choose? It will just be 1, right? And 1 unit is original. And then we times 100 to change it into percentage. You could write this in fraction. The advantage of writing in fraction is what I prefer as well, is that you don't have to do any kind of rounding off, and the answer is always in the most exact. Yeah? So it's 16 whole to 3%. All right, that's all for today. Thank you for tuning in again. Chaps.